Hello there! I'm Andrike Sky, and in this video I'll be doing a lightsaber conversion for a friend of mine. If you've been subbed to this channel, then you may have watched a previous video which involved my lightsaber install. However, this time I'll be working with different components for this hilt. If you want to check out that video, then you can watch it after this one. This is the Saberforge Archon hilt, which is in a Stunt Saber configuration. I don't know what color the LED for this one was previously, but it doesn't matter since this will be replaced with a Tri-Cree RGB LED for full color mixing. I don't recommend Saberforge for their questionable reputation, but if anyone wants to get this hilt anyway, I'll put it in the description. It included a kill key for the charge port, which I'll be replacing with a new charge port, since this one cannot be used for the conversion. It also included a blade plug, but it's way too short to fit in the actual socket. It's tightened by a retention screw and placed right at the top of the emitter. Here's the original battery holder for the Stunt Saber electronics and the included battery. The battery holder will be replaced by this chassis. However, these battery tabs are both leaf-shaped, so I had to modify one of these tabs in order to make the battery fit. Here's the Tri-Cree RGB LED that I'll be using. Technically, the blue is a royal blue, so it shines a much deeper hue than a traditional blue dye. With this LED, the colors will be very bright, but not nearly as bright as a NeoPixel Saber. Following that is the thermal tape for the LED to be taped on top of the heatsink. For the colors to be focused into a smaller area, the lens cover will be used. All of these LED components will be put into this heatsink module. There are holes drilled so wires can slip through and connect to the chassis. Here's the same speaker type I used in the last install, which is a 28mm 4-ohm 3W speaker. However, because of the speaker type, I would have to adjust the volume level for this build. Lastly, here's the soundboard. This time I'll be using a Verso 2.0 soundboard since this is a basic RGB build. It will still have the most essential features such as smooth swing, color changing, font selection, etc. However, the customization is very limited with this one. All of the settings are configured within the config file. I have the wire kit from the previous install, but this time I also got a few colors of 24 gauge wire. And I'm not going to use the 22 gauge wire since the wiring for this install doesn't require as much power. Here are two resistors we'll be using for the LEDs. I got a 1.1 ohm 2W resistor for the red LED dye and a 0.33 ohm 2W resistor for the blue LED dye. We don't need to use a resistor for the green LED dye due to the equal voltage values from the supply and from the forward voltage. I used this LED calculator from the custom Saber shop to understand which kinds of resistors I need for each LED dye. The values don't have to be exact, but they should still be close enough to the desired resistance. Now we can go over the tools. I have my soldering iron, brass wool tip cleaner, soldering wire, helping hands, heat shrink, E6000, and multimeter. This multimeter was only used for identifying which LEDs are which. Pretty handy to have in case you don't know the LED dye's location. Red is very obvious, but the other two were very difficult to tell until they were lit up. Oops, I forgot the Allen key and the tweezers. The Allen key in particular will help remove the original LED module with a set screw, and then replace the LED module with the new one afterwards. Alright, let's start disassembling the whole lightsaber. The only piece that I'm able to thread out normally was the pommel. The rest of the internals have to be pried out with a long stick such as a screwdriver. The button and the charge port were held in by glue, but they were still not easy to get out. The angle was awkward and it was stressful to avoid scratching the hilt in the process. After managing to carefully pry out the internals, I removed the LED module, button, and charge port. Since the wires are preventing everything from being taken out, I had to cut them with my wire cutter. None of these components and wires are going to be used anyway. When I tried to test fit the chassis, the CoverTech wheel screw was too long, and it prevented the chassis from being inserted, so I had to loosen the screw to continue. I had to remind my friend to purchase a shorter screw for the CoverTech wheel so he can still use it. Anyways, we can proceed with the actual install. I measured enough wire for the components from the hilt and I cut to length. I started with the Tri-Cree LED where the positive wires will all converge into the center hole, while the negative wires will be laid outside. Honestly, figuring out how the wires should be positioned was a little tricky, since they have to be moved well enough without any issues. The resistors will be connected in between the negative wires of the respective LED dyes, and then heat shrink will go over them to protect those connections. Meanwhile, I was rudely interrupted by uninvited guests on Discord. What do you want from me? I'm recording. Here's me waving at the camera with the soldering iron. For a whole hour or so, I talked with them and worked on the solder job of the LED. Then I peeled off the plastic layer off the thermal tape, took off the tape from the perforated lines, and aligned the tape with the LED. I messed this part up a couple of times, realizing that there's a certain order to follow before it's too late to go back. It sounds really stupid, but I was distracted with the conversation, and as a result, I rotated the thermal tape the wrong way, and I had to redo the tape placement. Once the tape was placed on the LED, it was ready to be put on top of the heatsink. I slid all the wires through the corresponding holes and made sure to apply gentle pressure on the LED to ensure the tape sticks on the top. From there, the lens cover was placed on top of the LED, and then the whole thing can be threaded into the shell of the module. After that, I worked on the charge port since the orientation felt confusing to learn at first, so I had to know which wires went in which stem. This is to ensure that the battery wires, as well as the soundboard wire, goes the correct way. I put the kill key into the charge port to make sure I can test it later. Now we move on to the button, which is technically 2 buttons on one PCB. This is pretty handy for a 2-button setup in hilts that have a 1-button design. For this soundboard, I had to connect the common wire to the positive side of the soundboard instead of the negative. The connections were pretty straightforward, so there weren't any issues with the orientation. After soldering the wires together, the actuator and the retention ring were placed together before threading the parts into the switch housing. This button should not be threaded all the way, as this would prevent the buttons from being pressed. That's all there was for the main parts. The battery tab I mentioned before was sticking out too far for the battery to fit, so I had to press it down with enough force to bend it far enough. Now the battery can fit into the battery holder, but I'll put the battery in after everything has been soldered to the soundboard. The battery wires from the charge port are soldered to the tabs, and the speaker wires are soldered to the speaker. Now everything should be set. All the positive wires will be connected into one wire to the soundboard, and the rest of the other corresponding wires will be connected to their respective slots. Again, I had the SD card removed before soldering the wires onto the pads of the soundboard. Compared to last time, I trimmed the wires a bit less for them to reach the soundboard. That way, wire management was easier to deal with. The battery was placed into the battery holder, ensuring the battery was oriented the correct way, and the kill key was pulled out. The boot sound was played and the Saber can be turned on. After testing whether the Saber turns on and the buttons work, I glued the charge port and the button onto the hilt. And now the conversion is finished. There aren't too many things I could show off in this one, but I'll show what this thing can do. That's all I have for this video. If you're curious about the in-depth process of lightsaber installs, then you can check out the previous video I did in the channel. Again, resources as well as helpful information will be in the description of the video. Subscribe to my channel if you want to. I'll post more of my VTubing content in this channel, so you can look forward to more funny and cool videos. I have a Twitch channel for my streams in case you want to see me, and a VODs channel if you happen to miss those streams. Thank you for watching this video, and I'll see you whenever and wherever. Goodbye!